Chapter 2, Lesson 4 of Pre-Calculus, we're going to look at the real zeros of these polynomial functions. In the last lesson, we looked at the end behavior by looking at the leading term, and then we also looked at the zeros and whether the graph crossed or touched at those zeros and what the shape was at those zeros. Now, in all of those polynomials that we looked at and the zeros in the last lesson, those polynomials were already in factored form. In other words, you had x minus 2 times x minus 3 times x minus 4, whatever it was, and each one of those factors helped us determine what the zeros were. In this lesson, we're not going to be given those factored form. We're going to have to determine the zeros for ourselves. And the way we're going to do that is division. You remember, division is a way of determining whether something is a factor of another number. If we take a number and we divide it by another number and the remainder is 0, meaning it divides in evenly, then that number is called a factor. So 24 is divisible evenly by 3, so 3 is a factor. It's also divisible by 4, so 4 is a factor. 24 is not evenly divisible by 5, so 5 is not a factor. So any time that we can divide and get a remainder of 0, we know that we have a factor. And we're going to use that with polynomials to determine whether these linear expressions are factors or not. We're not going to look at the long division algorithm. We'll maybe take a look at it when I talk about synthetic division, but right now in this lesson we just want to look at the remainder and factor theorems and what they do for us. The remainder and factor theorems allow us to determine whether a linear expression is a factor of the polynomial or not. In other words, if we have a linear expression, x minus some value, let's call it k, we can tell if this is going to be a factor of the polynomial. In other words, if we divide this into the polynomial, will we get a remainder of 0? We can tell that what the remainder is going to be by using the remainder theorem. So the remainder theorem is a way of determining what the remainder is going to be before we even actually have to divide, because really the only thing we're interested in is, will it come out even? Because if it comes out even, then it's a factor. So if I have a linear expression x minus k, if I take this k number and substitute it into the polynomial into which I'm dividing and then simplify it, the number that I get is going to be the remainder when I actually do the division problem. So the remainder theorem will allow me to determine what the remainder is going to be if the divisor, what a name, if the divisor is must be linear first. So the k, this x minus k must be linear, meaning the highest exponent is a 1. We take the k, we substitute it into the polynomial and simplify it, and that number that we get is going to be the remainder that I will get when I go ahead and do the division problem. So I can tell ahead of time whether this is going to be or divide evenly or not. Now, if it divides evenly, it's a factor, because a factor is any time you get a remainder of 0. So the factor theorem says if you divide x minus k into a polynomial and you get a remainder of 0, then this will be a factor of the polynomial into which you're looking. So again, the divisor must be linear and the remainder must be 0. Then we have this. So combining these two theorems together, we can determine whether a linear expression is going to be a factor of the polynomial before we even go through the process of doing the devising. Why do I keep saying stuff like that? Before we even do the process of dividing. Okay, so a couple of questions you should all know the answer to. So why is it important to know if a linear divisor is a factor of the polynomial? Why would we need to know that? Well, if it's a factor of the polynomial, that's going to allow us to determine what the real 0 is, and that is what we're interested in, the real zeros. Second question, what purpose then can we use the remainder and factor theorems? Well, working in concert, we can use these to figure out what the factors are, which gives us the ability to figure out what the zeros are, which is what we're interested in. Okay, so a couple of examples before we then take a look at synthetic division. So for an example, we want to use the factor theorem to determine if the polynomial is going to be a factor of the second. So is x minus 1 a factor of this? And again, the question means, will this divide into this evenly, giving us a remainder of 0? Well, the remainder theorem says if this is a linear expression, which it is, I can take this number 1, the k, and substitute it into the expression, and whatever value this simplifies to, that's going to be my remainder when I actually do the division. So let's go ahead and figure out what that's going to be. 1 cubed minus 1 squared plus 1 minus 1. So 1 minus 1 plus 1 minus 1 is going to be equal 0. So my remainder when I do the division is going to be 0, which means that x minus 1 is a factor of this polynomial. And it's that simple. So let's do a couple more examples. So in this example, I have a linear expression. Will this be a factor of this? Meaning, when I divide this polynomial by x plus 2, will I get 0? Well, I can determine what the remainder is going to be by doing x minus, remember it's x minus k. So I'm going to need to take negative 2 and substitute it into the expression, simplify it, and see what number I get. And whatever number I get, that's going to be my remainder when I actually go ahead and do the division problem. So I substitute in negative 2 and simplify this. So negative 2 cubed is negative 8 times 4 is negative 32. Negative 2 squared is 4 times 9 is 36. Negative 3 times negative 2 is positive 6. And then this is negative 10. So this negative and this negative is negative 42. 36 and 6 is positive 42. When I add those together, I get 0. So when I do this division, I am going to get a remainder of 0. And because I have a remainder of 0, the factor theorem says x plus 2 is a factor of this polynomial. I'll do one more example, and then we'll wrap this up, and then we'll take a look at synthetic division in the next video. So is x minus 3 a factor of x cubed minus x squared minus x minus 15? So again, I can take the k value here, which is 3, substitute it into the expression, and then as I simplify it, whatever value I get will be the remainder when I go to do the division. So 3 cubed, is 27. 3 squared is 9 times a negative 1, that's negative 9, minus 3 minus 15. So this is 27, and then negative 9 and 3 is negative 12, and negative 15 is negative 27. I add those together, I get a 0. So because my remainder is going to be 0, the factor theorem says that x minus 3 is a factor then of this polynomial. So you can use the remainder theorem and factor theorem together to determine whether this will be a factor of this or not. In the next video, we're then going to learn how to confirm this by actually going ahead and doing the division problem and getting the remainder that we say we're going to get using the remainder theorem.